Hello everybody and welcome to this presentation from Hayley Marie Keith from Mito Material Solutions, who's going to give us a talk on functionalization graphene to enable a lower price barrier of entry for advanced materials. As always, we'll take your questions live at the end of this talk, so please leave them in the sidebar. I'm now going to hand over to Hayley and I'll see you again at the presentation. Over to you, Hayley.
Thank you so much. Thank you everyone for allowing us to be here. I'm very excited to talk with you today about what Mito is doing. So at Mito Materials, we really formulate high-performing additives from traditionally hard-to-use materials. Our focus is authenticity and sustainability and science and education because you need a lot of that when you're dealing with a brand new material like graphene. So I'm sure everybody has heard a lot about graphene today, so I'm not going to talk to you about the things you already know. Graphene is known, and it's getting more known in a lot of different industries, and that's great. But sometimes it's known for the shortcomings that it has, right? It's really difficult to disperse, it clumps together, the platelet sides collapse, and that can cause integration issues when you're looking at applications. But ultimately, we know that as an industry, we can solve those problems. And Mito's here because we truly believe that this material will unlock the next generation of materials and innovation in our new world. So instead of looking at graphene, Mito actually took a look at graphene's cousin first, graphene oxide, because of the issues with dispersion that we found in the marketplace. And when I interviewed and talked to different companies within the market space about nano additives, carbon nanotubes, some of the biggest things I heard were it needs to disperse really, really well because the agglomerations cause other material defects that cause major issues down the line. It needs to be able to integrate well into our manufacturing process because we don't want to spend time or money implementing a new material. That's just an immediate turnoff. And the other thing is it needs to scale. Graphene as an industry has been scaling for years. And if you're going to create an additive made out of graphene, the process better be pretty scalable pretty quickly because once the adoption takes place, as we all know, large amounts are needed. So in looking at graphene's cousin, graphene oxide, our chemists took a look and said, the shortfalls that the layers can stack quickly. They require carriers to remain usable, and they're a lot of the time produced with a modified Hummer's method. Looking at these oxygen sites, we believe that if chemically compatible and used correctly, we could make graphene chemically functional and highly dispersible. And that's what we did. So at Mito, we've developed a process that uses GEO to attach to other physical polymers to enable the chemistry compatibility and dispersion, unlocking graphene's true potential at concentrations ranging from 0.03% to 0.1% by weight of the part A. It's a single batch process and extremely versatile. We can plug and play different polymers in between the despacing of the graphene platelets and customize that platelet spacing for adequate dispersion. We have an extremely high output, and the process is scaled already into industrial size facilities as we have been growing as a company. We believe that this functionalization process and our method will truly unlock the potential of solving key issues based around the science and the chemical and physical functionality. So our first pairing was a polymer called POS, polyoligomeric cyclohexane, as it is very scientifically known. We chose this material in this particular particle because of the epoxide groups that stem away from the cage structure of the silicon. These epoxide groups allow chemical functionality in many part A's for polymer composites and even some thermoplastic settings. The polymers are interchangeable. We've worked with different types of POS that have different chemical arms like methacrylate, acrylate, and are looking into several others with our formulations. But this one was a well-established pairing, right? Everybody kind of knows what POS is. They've put it in epoxies. It has some of the same problems. It agglomerates if you put too much in. But you do get improved mechanical properties, improved thermal properties, and those properties complement graphene's promise and potential very well. That led us to Mito's flagship EGO, which is a combination hybrid of POS and graphene oxide. We have used EGO in a variety of different applications, characterizing it in multitudes of polymers, and have found performance increases at 0.1% of the polymer. In these increases range anywhere from mechanical at 135% to thermal conductivity over 20% to electrical conductivity near negative 86%, making it an extremely resistive material. Enabling the next generation of materials is possible with Mito